Assalamu alaikum everyone. Myself Anika and registration number 21TE54. Today I'm going to tell you the basic plotting of the signals by using the MATLAB. Here the task number 1 is, in the context of digital signal processing, we have to elucidate the essence and indices encapsulated within the term digital. So, in the digital signal processing, the term digital refers to the representation of the signal by using the discrete values like binary digits or bits, zeros and ones. The essence of the digital aspect in DSP lies in the quantization and discretization of the signal. This basically involves taking a continuous signal and then converting it to the discrete values at the specific intervals we have. And the word interstices is basically it comes with different terms like discretization. It includes sampling, it includes quantization, and it includes the processing algorithms. I will explain these terms to you one by one. Basically, discretization means the digital signals are discrete in both amplitude, in both amplitude and the time, and the amplitude is quantized into the distinct levels, and the time is then divided into the discrete intervals. And this basically allows for the representation of the signal by using the binary digits. Then comes to the sampling. Sampling involves capturing of the amplitude of the continuous signal at the regular interval. Uh, as sampling is basically conversions of analog signal into the discrete form by taking the finite points. Uh, and then it comes to quantization. Quantization is just like once a signal is sampled, the continuous amplitude values are approximated to the discrete values, and this process is called quantization because it is only continuous to the x-axis, so we have to do it on the y-axis also. So for that we use quantization techniques. And processing algorithm. In the digital domain, the signal can be processed by using the algorithm and the mathematical operations. So this allows the efficient manipulation and analysis. So digital filters and transforms and other processing techniques can play a vital role in the digital processing. So the task number 2 is we have to explain that how does the choice between the linear search and the binary search in DSP application illustrate the relationship between the digital data and the sorting. And then we have to tell what are the implications for data processing efficiency. So first of all, let's have a look on the linear search. Basically, in the linear search, the data is examined sequentially. Like it will check the numbers one by one. First, it will go on the first one, then it will check the second one, then third one, then fourth one, and then so on. And we will check that our desired number is in which sequence, in which order they are given. So now binary search is that we divide our array in two parts. So in the mid one we check that the desired result is on which side, either it is on the left side and either it is on the right side. In the binary search we get the result quickly as compared to the linear search. From the word binary we come to know that it is in the form of zeros and one, so it represents the digital data. And uh, and the binary search is more common in the digital signal processing. uh, the binary search is very fast as compared to the linear search, and in the linear search the step by step, it is according to the step by step nature, like I have told you before that it will check the numbers sequentially. So here the time consumption is more, and it is not linear search is not used in the digital data. So the implications of the binary data include like it is more efficient for the large data set, either the data is in the sorted form or not. The task number 3 is, in the domain of the digital data, what are the strategies and the techniques that can be employed to enhance the data transmission efficiency? So basically there are in the time domain of the digital data, Enhancing the data transmission is very crucial for improving the communication reliability. There are many strategies and the techniques that are used to enhance the data transmission. Some of them are just like data compression and error detection, error correction, and multiplexing. There are so many multiplexing techniques, and we have rate control, bandwidth management. So basically, what is the error detection and error correction? For implementing the error detection and error correction codes, they help us to identify and fix the errors that are present during the transmission time. And after that, the data compression techniques are also used to reduce the size of the data, and they will also allow the faster transmission of the signals. And then we have multiplexing technique. There are so many multiplexing techniques, and multiplexing is basically it allows the multiple signals to be transmitted over the single communication channel. Some examples of the multiplexing technique is time division multiplexing, which we can say TDM. Then we have frequency division multiplexing, and then we have code division multiplexing. After that, we have bandwidth management, which allows the management of the bandwidth to avoid different noise and like that, and to ensure the smooth data transmission over the long period of time. Then we have channel coding also. If we use the channel coding techniques, we can encode the data, and same like we can do efficient transmission and do the error recovery also. Okay, so this one is the lab task number 4, and in this one we have to simply plot the sinusoid signal in the MATLAB, and we have to check what is the effect of time, what is the effect of frequency, and what is the main relationship between the time and the frequency. First of all, in the MATLAB code we are using T. T is used for time period, and here we have taken the time period that is from 0 to 1. Then F is used for frequency, and here the frequency is 1, and then we have used the command of signal. Whenever we have to plot any signal in the MATLAB, we will use this command, and we are using the sine wave sinusoid signal, so that's why we have used sine 2 pi f of t. And whenever you have to plot any function in the MATLAB, you use this command, that is plot. And we are plotting the signal in the time domain, that's why we have used plot t signal. So let's run this and let's see what will be the wave of this function. Okay, so this is the simplest wave of this function, and it is starting from 0 and it is ending on 1. So let's see what is the effect of changing the time period. First, we have used the time period that is 0 to 1, and it is representing on the x-axis. Now let's change it, and 0 to 2. We have increased the time period. So by increasing the time period, the signal will be plotted over the long period of time. Signal is from 0 to 2. This is the time period of this signal. Next, let's change the frequency. Let's suppose that frequency is 2. Okay, now look, if we increase the frequency of the sine wave is increased. This is a sine wave and its frequency is increased. This means the oscillations are increased. These are the oscillations, and by increasing the frequency, these oscillations have been changed. And the main relationship between frequency and the time period is that both of them are inversely related. If one is increasing, the other one will decrease. So that's it. So this one is our task number 5, and in this one we just have to look what are the impacts of the X label and Y label, labels and titles basically. So from here to here the function is same as we have done in the previous one. We just plotted a sine wave, and we have checked what is the impact of the time period and the frequency. Now we have to we have to give the title and labels. For the title, we have used the command title, and what is the title that we have given? It's simple plot of sine wave 1 Hz. Then we have given the labels. There are two x's. that one is x-axis and other is y-axis. So for the y-axis we are using the label that is amplitude, so it will show the word amplitude over the y label. And for the x-axis we are using this sentence, that is time in seconds, so it will show this word over the x-axis. And what are the axes? The axes for the x-axis, they are starting from negative 0.5 to 1.5, and for y-axis it is showing minus 1.5 to 1.5. Now let's run this function. First it will just show a sinusoid wave like this, and look, now we have the labels and the title is showing over here, that is plot of sine wave 1 Hertz. And on the x-axis, on the x-axis we have time in seconds, and on the y-axis we have amplitude. These are the labels. So on the x-axis it is showing from negative 0.5 to 1.5, and on the y-axis we have negative 1.5 to 1.5. If we change these labels, for example, let's change the labels. On the x-axis, if we say we have to show time in seconds in both, let's say here we have to show seconds. Now run. Now in the y-axis, the label y and x-axis, the labels have been changed. We have time in seconds and seconds. So whatever title and label you want to give in your graph, you can just simply add y label, x label, and the title. So that's it. The next task is to plot the multiple signals. For that we have taken the time period, that is from 0 to 10, and here we are using two different signals. So for that I have taken two frequencies, one is 10 and the other is 520, and we are using two signals, signal 1 and signal 2. Then again the plot command, because we have to plot both of these signals, so that's why signal 1 and signal 1. We can also say signal 1 and signal 2. Okay, next one, we have given the title, that is plotting multiple signals in the same figure, and the next one we have given the labels for the x-axis and y-axis. On the y-axis we have given the label that is amplitude, and for the x-axis we have given the label that is time in seconds. And same for the axis, we have given the x-axis that is starting from 0 ending on 1, and for y-axis it is starting from minus 1 ending on 1. Now let's run this function and let's see what will be the output. Okay, this one is the output of the signal. As we are using two signal, one is representing with the red one, other is representing with the blue one. These are the two signal, and see, these are the labels. On the y-axis we have amplitude, on the x-axis we have time in seconds, and this is the label. In the next lab task you have to show the signal without connecting the dots. So for that we have taken again the time period and two frequencies, and for that we have taken the signal and then plot command, then hold on, next signal, then again plot and hold off. In the next one we have given the title and labels, x label, y label, and we have given the axis, that is for x1 we have given 0 to 1, and for y minus 1 and 1. Title is plotting without connecting dots. Let's run this function. Okay, so this is our output. Now look, these are the dots and they are not connected. They are not connected with each other. They are just showing simple dots for both of these functions, both of the frequencies f1 and f2. One is shown with blue one and one is shown with the red one. So here is the next task, that is you have to generate a random variable from the uniform distribution, and then you have to calculate its mean, and you have to plot it. So first of all, we have taken a number that is 50 and we are representing this number with n. N is equals to 50. Then we have taken a random variable that is representing with r and n1. Here the n is showing the number and that is 50. Then in the MATLAB, as you know, we always use the plot command to plot it in the graph. So after that, draw a line from 0m to nm. This is used for x-axis and this one is used for y-axis. Here m is mean. Then you have to plot x-axis and the y-axis, then hold off and title. The title is mean of random uniform data. So let's run it. This is the graph that we got. We have calculated the mean and the random data from the uniform distribution, and this is the graph. Okay, so the next lab task is we have to define the minimum function, and we have to take mymin function that will take a vector as an input and then it will return the minimum value from that vector. So for that, first of all, we have initialized our vector. We have taken my vector and here we have taken some random values in this vector. You can take any value of your own choice here. And after that we have called our function, and the function is stored in the variable that is result. And after that we have displayed our function, and here we have used the num to string. Here it will convert the numerical values into the string. After that, function min value is equals to my min vector. It means it will define the function that is my min. After that, if it's empty vector, error input vector is empty. After that it will end. What does this mean? It means that the function will first check if the input vector is empty or not, and after that if it is empty, the error message will be displayed, and end means it will stop. And if it is not, so it will display the minimum value from our vector. So let's run this function. So the output is minimum value in the vector is 1. Minimum value in this vector is 1, and that's correct. Okay, now we have to display the maximum function that is same as the previous one. In the previous one we have taken the minimum value, and now we have to check for the maximum value. All of the things are same. There is just one difference, that now it will tell us the maximum value from our vector. So let's run this function. So here the maximum value in our vector is 9. Okay, here what we have to do, we have to make an average function that will take a vector as an input, and then it will return the minimum value from our vector. Again the same thing, we have taken a vector value, and I have taken random values of this vector, and I have used the average function. After that I have displayed the value of average value of the vector, and we have used the string that will convert the numerical values into the string. And after that, the same thing, that if it is empty, the error message is displayed and it will stop, and if it is not, then it will display the average values from our vector. So the average value from my vector is 3.875. After that, the next lab task is, now we have to sort our vector. I have taken the values of the vector 3145,926 and I have used the sorted result. I've used this to sort my vector. I've used this function my sort my vector, so it will sort my vector. Sort means arrange. So let's run. So look, first of all I have an unsorted array. Now in the output it is given the sorted array to me. Simply the next one is there is a vector that is given. Now I have to reverse this. So how I will reverse it? I have used my reverse function. It is a built-in function that I have used, and I have displayed it, and again I have declared the error, that if there is any error, it will check it, and if the error will be displayed, it will stop, otherwise it will reverse my vector. So let's run this function. This is our array that is reversed. This is a reversed array. First of all, I have 3, 1, 4, 5, 9, 2, 6, and in the output it has reversed my array, so the output is 6, 2, 9, 5, 4, 1, 3. In the next lab task, what we have to do, we have to draw the multiple plots in the one figure by using the subplots. So first of all, we have given the time, that is from 0 to 0.5. Then we have taken the random variables, that is starting from 50 and ending on the 1. This is the range of our random variable. Then we have taken the y function, that is the sine function, and that is 10 2 pi of t. And now we have used the subplots. Subplot for x is this one, and subplot for y is this. Now let's run this function, and let's see what will be the output. This is the output. We have two graphs for this function. One is for x-axis and one is for x and other is for y. In the next lab task, what we have to do now, we have to do the same thing with four subplots. So first of all, our function is when 4. We have defined our function. We have taken four functions. One is sine, one is cos, one is tangent, and one is exponential function. Then after that, for all of these, we have taken the title, subplots, and subplot for x and y, both of these. So when we run this function, so see, we have four plots for all of these functions: sine, cos, tangent, and exponential.